If you are someone who loves mathematics, then this video is for you. I'm not going to do anything regular in this video, but I'm going to show you a really cool approach to solve this particular problem that's there on the screen. I'm going to provide a very fresh perspective of solving algebra questions using trigonometry. I know that sounds surprising, but that's what we are going to do in this particular video. So I was going through All India Test Series papers of FIITJEE and I found this question. The question is simple. So you have a numerator, which is a summation, and you have a denominator, which is another summation, and you just have to find the ratio of both the summations and give the integral part of that fraction as your answer. That's it. But the difficult thing here is that the square roots that you have are nested square roots. So you have the square root outside and one more square root inside. So the algebra is going to get really, really messy. And one more thing to be noted is that this is a very famous question, and this question appears on All India Test Series of different coaching institutes every year. So you should have already done this question, or you might be already knowing the solution for this, but we are not going to solve it in a regular, trivial, conventional method. So, and in case if you don't know how to solve this question, I would really recommend you to pause this video at this moment and give this question a sincere try. So with that, let us jump in. So the summation that you have in the numerator looks something like this. You have square root of 10 plus root 1 term here, square root of 10 plus root 2, and it goes all the way till square root of 10 plus root 99. And the similar thing happens in the denominator but with a minus sign. Alright. So we have to compute these summations. Now what we are going to do is, so let us consider, so like there are some questions that you should ask yourself at this point in time. So why does the summation end at square root of 99? Why did the examiner did not ask you to calculate this particular summation uh, till 50 or some other value? So the answer might be that, so once you go beyond 99, this term will become negative. And if he's asking till somewhere like root 50, the question doesn't look beautiful. There is a pattern that is being followed here. So by looking at these numbers, you should get a hint. Okay. So what hint? I mean, like, what does this say? So what is some intuition that you can develop? So if this is a right angle triangle, and if you consider the hypotenuse as 10, then, and if you consider this side as root 1, then this side will be root 99. If you consider this as root 2, then this will be root 98. If you consider this as root 3, this will be root 97. So the thing that is happening is that this 10 is always constant, and that's what happens in your summations. It is 10 everywhere. All right. Now, if you assume this is theta, all right, and this side as root of n, since n is already used in the question, let us say this is root p, then this side is simply your 100 minus p, under root of 100 minus p. That is what you have. Now what you can do is, you can consider this term. See, if you consider this particular triangle where you have root 1 and root 99, so root 1 appears in this term and root 99 appears in this particular term. So what I'm going to do is, I'm going to take those two terms in my summation instead of taking all the 100, all the 99 terms. All right. So I'm going to consider this particular summation. So let us say this is S, and let us say the value of this summation is A. All right. I have considered this particular summation. This is 99. So now what I'm going to do is, I am going to divide the numerator by root 10. So then this will become square root of 1 by 10. plus root of 1 plus root 99 upon 10 under divided by square root of, I'm going to do the same thing in the denominator as well. Then this will become 1 minus root 1 upon 10 plus square root of 1 minus root 99 upon 10. So let us say this is S. Alright. Now if you carefully observe, your root 1 upon 10 is simply cos theta, and your root 99 upon 10 is simply sin theta. Alright. So your expression is simply 1 plus cos theta plus square root of 1 plus sin theta by square root of 1 minus cos theta plus square root of 1 minus sin theta. So instead of taking this particular term, even if you take root of 10 plus root 2 plus root of 10 plus root 98 by square root of 10 minus root 2 plus square root of 10 minus root 98, you will get the same expression. So it will be always root of 1 plus cos theta plus root of 1 plus sin theta, but your cos theta and sin theta will change. If you consider this particular term, your cos theta will be square root of root 2 by 10, and your sin theta will be root of 98 upon 10. So this will change, but your expression is same. All right. So now let us go ahead and solve for S. All right. So once you look at some expression like this, it is a very common idea to rationalize. So you have to multiply and divide this expression using 1 minus cos theta minus root of 1 minus sin theta, and here also 1 minus cos theta minus root of 1 minus sin theta, root of 1 plus cos theta plus root of 1 plus sin theta. So this is your S. All right. Now if you check the denominator, so if this is your A and this is your B, this is A plus B and this is A minus B, so that is A square minus B square. So your A square is this 1 minus cos theta minus B square is 1 plus sin theta, and in the numerator when you multiply this and this, you will get root of 1 minus cos square theta, but 1 minus cos square theta is sin square theta, and that is inside the root, so it is simply sin theta. Similarly, when you multiply these two, you get minus 1 plus cos theta times root of 1 minus sin theta. When you multiply these two, you get root of 1 plus sin theta multiplied by root of 1 minus cos theta. But when you multiply this term and this term, you will get root of 1 minus sin square theta, which is simply cos theta. So this is simply cos theta. This will be actually minus cos theta. So this is your S. All right. So in the denominator, this and this will get cancelled, and what you have in the denominator is sin theta minus cos theta. If you observe, even in the numerator we have sin theta minus cos theta. So you can split the numerator and write this as 1 plus, what will you have in the numerator? 1 plus sin theta multiplied by 1 minus cos theta minus root of 1 plus cos theta times 1 minus sin theta upon sin theta minus cos theta. This is what you have, S. So send this one to that side and it is simply your S minus 1. All right. Now let us see what S minus 1 whole square is. Mind you, S is a function of theta because your left hand side expression is in terms of theta. So when you do S minus 1 whole square, in the denominator you'll have sin theta minus cos theta whole square. So when you expand that, you'll get sin square theta plus cos square theta minus 2 sin theta cos theta. So but this quantity is equals to 1. So replace that with 1. And when you expand the numerator, so for this term, you will be getting 1 plus sin theta minus cos theta minus sin theta cos theta. and minus for this particular term, when you square that, you'll be getting 1 minus sine theta plus cos theta minus sine theta cos theta. And then there is a 2ab term. So minus 2a is 1 plus sine theta, 1 minus cos theta, and b is 1 plus cos theta times 1 minus sine theta. This is what you have. So let us forget about the denominator for some time and focus on, I made a mistake. So this is actually plus. So if you consider the numerator, it will be 1 plus sine theta minus cos theta minus sine theta cos theta plus 1 minus sine theta plus cos theta minus sine theta cos theta, and here you have minus 2. When you multiply this term and this term, it is root of 1 minus sine square theta. So that will simply give you cos theta. Similarly, these two terms will give you sine theta. So now in the numerator, if you see, this and this gets cancelled, this and this gets cancelled, and what you have here is 1 plus 1, which is your 2, and this is minus minus minus. So minus 4 sine theta cos theta. So therefore, your s minus 1 whole square, s minus 1 whole square is equals to 2 times 1 minus 2 sine theta cos theta. And in the denominator, you will have 1 minus 2 sine theta cos theta. So this and this gets cancelled, and your s minus 1 whole square is 2. See how beautiful the result is. So your s, which we assumed was a function of function of theta, turned out to be a constant value. All right. So we know s is a positive quantity. All right. We know s is a positive quantity. So we take only s minus 1 is equals to root 2. All right. Therefore, s is 1 plus root 2. See how beautiful the result is. Your s is simply 1 plus root 2. So therefore, this particular s is 1 plus root 2. Similarly, when you take this, all right, so your square root of 10 plus root 1 plus square root of 10 plus root 99 is equals to root 2 plus 1 times square root of 10 minus root 1 plus root of 10 minus root 99. This is what we got. Even when you take 10 plus root 2 plus square root of 10 plus root 98, this will also be is equals to root 2 plus 1 times of square root of 10 minus root 1 plus square root of 10 minus root 98. All right. So therefore, in the numerator, so this term can be replaced with this particular thing, and this term can be replaced with this particular thing. So what you will have essentially at the end is root 2 plus 1 times of root of 10 minus root 1 plus root of 10 minus root 2 plus and so on plus root of 10 minus root 99. This is what you will end up getting in the numerator. And in the denominator, you have the same thing. This thing is present in the denominator as well. So these two will get cancelled. And the value of the actual summation which is asked in the question, actual ratio which is asked in the question, is simply square root of root 2 plus 1. This is around 2.4. So therefore, the integral part of that particular ratio is simply 2, which is the answer for your question. I hope you have understood the solution that I have presented, and I hope you have liked the video. So if you find this approach cool, do not forget to give this video a thumbs up, share it with your friends, and subscribe the channel for more such content. And if you do not know how to solve this in a conventional method, let me know in the comment section. I'll make one more video on this where I'll be solving it in a conventional way. And also there are a lot of fantastic videos on the YouTube channel. Make sure you check them out. If you have any other queries, comment section is the way to reach out to me. Thank you. I'll be meeting you in the next video. Till then, take care.